So in this video, we're going to do an application of the quotient rule again, but we want to look at a case where we need to, or where we want to rewrite the function before using the quotient rule in order to make our lives a little bit easier. So I want to find the derivative of f of x, and f of x is equal to 2 plus 1 over x all over 1 over x squared plus 1. And I do have an x in the denominator position here, so we know that x can't be 0. We could just use the quotient rule because we do have a ratio of two functions, so we could apply the quotient rule, but this is a case where we can clean things up a little bit first to make our lives easier. And what we want to do is focus on the denominators. We have x and x squared. So the least common multiple of x and x squared is going to be x squared. And what we want to recognize is that if we multiply something by x squared over x squared, that this is going to equal 1 as long as x isn't 0. And in this case, x can't be 0 anyways. So I'm going to multiply this by x squared over x squared, the least common multiple of x and x squared. And then I'm going to distribute the x squared in the numerator position into the numerator here. So I'm going to get 2 times x squared plus, and I have 1 over x times x squared is just x, right? 1 over x times x squared is just x, all over. Distribute the x squared in the denominator into the denominator here. So x squared times 1 over x squared simplifies to 1, plus x squared times x is just x squared. And now I have a rational function that looks a lot cleaner than the complex function that I had up here. And this is going to be easier to apply the quotient rule to than the original function. So now I'm going to go ahead and find the derivative. And the quotient rule says simply to take the derivative of a ratio of two functions. First, take the derivative of the function in the numerator position. 2x squared plus x is in the numerator position, so I have a constant multiple. So 2 times x squared, so it's going to be the constant times the derivative. And the derivative of x squared is just 2x, plus the derivative of x is just 1. So there's the derivative of the numerator times the denominator function. So in this case, my denominator function is the x squared plus 1 that's sitting here. Subtract the numerator function, 2x squared plus x. The numerator function times the derivative of the denominator function. And the derivative of the denominator, the derivative of a constant 1 is just 0, plus the derivative of x squared is just 2x by the power rule. And this will all be over, from the quotient rule, the square of the denominator function. So take that x squared plus 1 in the denominator and square it. And now clean things up a little bit. 2 times 2 is 4x, so we have a 4x plus 1 times an x squared plus 1 minus, and here I have a 2x squared plus x times a 2x, and this is all over the x squared plus 1 squared equals, I see that I have a common factor of x here, so I probably want to factor that out and combine it with this. So in other words, 2x squared plus x can be factored as x times 2x plus 1. And I already have a 2x sitting over here, so I have a times a 2x. So the 2x times x could give me a 2x squared times the 2x plus 1. So I would do that simplification process to this. So I'd rewrite this as 4x plus 1 times an x squared plus 1 minus the 2x squared times the 2x plus 1 all over the denominator squared, or the x squared plus 1 being squared in the denominator. And then I want to look and see if anything else will factor easily. And if nothing else will factor easily, then I think that's probably good. Doing this step here, I think, was simple enough that it should be done.